Since I'm involved in some group activity, who is working on to pick up the right topics for the next technological feature of the industry. So I have to deal with the two things by juggling two items. By the way, let me get back to the talk regarding how we can generate the end-fire radiated field, which has the wideband in terms of antennas which are going to be reside on the LEO satellite. So this is the outline of my talk, which includes the keywords you might be intrigued with and technological trend in the industry covering LEO or other orbit or residing satellites. And the proposed antennas will shed a light on how we can approach the design of the antennas, which give us the wideband as well as the end fire. End fire here means if you have a gun, when you fire the gun, the shooting occurs at the end of the gun. So that's how it works. And I will reach the conclusion. The keywords, which include LEO satellite and end-fire wideband for S-band. S-band is a specific frequency band that is allocated to cube or small satellites, which will be launched to the low Earth orbit or middle Earth orbit, such as LEO and MEO kinds of things. In low Earth orbit, so-called LEO satellites, these days people are interested in the industrial development of the satellites to observe physical or meteorological phenomenon on the surface or over the surface of the Earth, not by deploying the geostationary satellites to the very far away from the Earth's surface, such as less than 2,000 kilometers in terms of the altitude from the Earth's surface. Usually that is what 800 kilometers or just around 1,000 kilometers from the ground, which is called LEO. You can find the definition of the altitude regarding LEO from the Wikipedia or other scientific reports. And it provides high bandwidth and low communication latency. The reason is we will rely upon the frequencies such as millimeter wave, K, Ka, or above. That's why people can deliver very wideband and a high data transmission, which will be expected by the implementation of LEO and MEO satellite industry. And most of the artificial objects in an outer space in LEO, they are targeting TV, radio, satellite phone, and satellite internet, etc. Still, these things are being planned by very pioneering people in NASA or other prestigious institutes all over the world. And my student could pick up the picture, which is available on the internet, which is part of a LEO project, Iridium Satellite LLC. As you can see, the what overall structure looks like a cube or other object, which is flanked with the two pairs of solar panels, which generate the electrical power, supporting the survivability of the satellite. This satellite should be very light compared to the geostationary satellite, which weighs usually 1 ton or 2 ton or 1.5 tons, etc. According to the program, space program, you can make a very variety of weights of the structure, but this should be less than 1 ton, such as 500 kilograms or so. When you try to miniaturize or specify the application of the LEO, to the CuBE project. CuBE satellite usually weighs around several hundreds of kilograms. So people need to economize the layout or the harnesses or other stuff which are going to be embedded inside of the satellite. So you can take a look at the useful information and possible documents you can refer to from the internet, because Iridium is a kind of open project to everyone. So you can approach how the devices that are going to be residing inside and on the surface of the satellites like this. But you can take a look at, pay attention to the word Ka band, which gives us a direction, which frequency band we are going to target at in terms of the design. Let me go back. Oh, sorry, let me move on. So this type of small satellite is being delivered in the transponder of a payload of a satellite like this. Shuttle, space shuttle or rocket holds this small-sized satellites, such as LEO or CuBE or MEO satellites inside of underneath of the capsule in the head of a space shuttle. What they say, SpaceX, which is going to be recyclable according to their program, different from the NASA's old tradition method of deploying the satellites into the right orbits. As you see, this rocket should return to the Earth instead of breaking into pieces while it is being launched to the space. And they launched already 143 satellites at once for establishing Starlink, which is business about satellite internet system, and so on and so forth. My student got a very interesting animation, which pushes us to work on the dual band antenna development for satellites. So as you see, RX and TX employ different frequency bands, even though the frequency bands are placed quite next to each other in terms of the Ku or Ka band. They would like to put the two functions together in one physical geometry. So, but this approach is not very new. Even in my group, we can generate one body with the two functions or multiple functions in terms of the bandwidth or the number of the bands and what the number of the beams, or whatnot. According to Project QUIPA, customer terminal antenna, as you see, two layers of the geometries which can accommodate the down and up links for communication between the ground and the space. And they got a picture of one huge structure, which looks like a kind of an array antenna, which is helpful to concentrate the beam toward the surface of the Earth. At the same time, by adding the switch matrix and a beamforming algorithm, which supports the feeding area of the antennas, we can shine the light on the specific covered area to make the link between the two areas in the sky and the Earth. And let me go to the point I would like to deliver to you. As you see, a Vivaldi type of antenna, you can modify this structure into your own taste. But here, one unit structure of Vivaldi antenna was selected to have a wide band. As you see, S11 as the reflection coefficient, which tells us which frequency band is going to be operated with the help of this physical geometry. And the far field pattern is accommodated with the real geometry like this. So if you are used to the design of the antennas, you know what this means. The far field pattern is put right next next or right above the surface of the Vivaldi antenna. Vivaldi antenna is quite often or commonly used for wideband. At the same time, we want to shine the light to the end or toward the longitudinal direction of the antenna. This is why it is called end-fire antenna. End-fire antenna, in contrast to the broadside antenna, you can find lots of advantages you can take. So this is the far field pattern coming from one Vivaldi antenna, which goes with this reflection coefficient, which tells us the bandwidth. But we were not satisfied with this function of the one Vivaldi antenna. We had to extend this to 1, 2, 3, 4, 1x4 array formation. So 1x4 formation gives us the higher directivity. The S11 or reflection coefficient or bandwidth performance doesn't change that much. But once you take this to the extension of 1x4 array antenna, this far field pattern changes to another one, which is totally different from what you saw in the previous slide. This shows you very pointy beam, which still is the end fire, goes along with the longitudinal direction of the antenna. So we suggest this 1x4 Vivaldi array antenna is attached to this area, one corner of the side walls of the cube or LEO satellite. We can increase the directivity of the far field pattern, quite helpful for the quality communication linkage between the ground and the space. And this is easy to be attachable to the surface. That's why my students suggested this end-fire broadband antenna coming with this satellite device. Conclusions are the not very new, but existing type of antenna, so-called Vivaldi or antipodal antenna, is one of the appropriate solutions to be attached to LEO satellite surface, considering the weight and considering the easiness of attachment of the structure to the body of the satellite. So when these two techniques are combined together, you can see some new approach, which is quite convenient and just one less costly approach for the satellite development. Thank you. If you have any questions, please leave me with the questions or curious points of your own in the chatting room or chatting window. 혹시 채팅 윈도우에 질문거리가 나오면은 나한테 좀 알려줘야 될 것 같고, 어떻게 그 이제 도우미 학생도 좀 알려주세요.
여기에 참여자가 채팅으로 질문이면
그렇죠. 그래서 뭐 질문인지 제가 물어볼게요.